What's up, everybody? Mr. Hanson at Mr. Hanson Form 4 today. We are here for another geometry lesson. Been pumping out those geometry lessons today, getting all my shapes on. So today, 6.3 HL, triangle congruence, HL. HL represents hypotenuse leg. It makes me think of the stanky leg. Don't ask me why, if you even know what that is. But anyway, so the essential question for today is, what does the HL triangle congruence theorem tell you about two triangles? Well, if a leg and a hypotenuse of one right triangle are congruent to the excuse me, to the corresponding leg and hypotenuse of another right triangle, the triangles are congruent. So you guys know I don't mess with these drawings, but the book wants us to see, is there a side-side angle? We haven't done that yet. And if you were to do it, long story short, you would not be able to show that SSA works because it doesn't describe a unique triangle. Just because you have two same sides and one same angle doesn't mean it's the same triangle. You could have the same, you could draw a triangle that has those two congruent sides and the congruent non-included angle, and then the triangles aren't the same. So your friend says there's a case of where SSA can be used to prove, namely when the non-included angle was a right angle, a different right. Well, technically, yes. Because in this situation, then, you know that if you have a right angle, that one side of the congruent sides would be legs, and the other side the hypotenuse. So if you know the leg and the hypotenuse, and you use Pythagorean Theorem, that thing always comes back, right, to make a unique triangle. So if you know that it is a right triangle, and you know two of the sides, we can always find the third side. That's really, you know that for a while. So let's justify that. Okay, so far we got four ways: ASA, SSS, SAS, AAS. Lots of letters. It's confusing. Make sure you know what each of these represent and have diagrams to go with them. So you know angle, side, angle is the angle, side in the middle, angle. You know side, angle, side is side, angle, side, where they meet. Side, 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 obviously three sides. Angle, angle, side, angle, angle, side, not included side. So the other one that we can do is hypotenuse legs. So legs are the short sides, short legs of a triangle. The hypotenuse is the side opposite the right angle. Okay? So let's get into it. Make sure you get the theorem down. So by the Pythagorean Theorem, a squared plus b squared equals c squared. So the two short legs, the two legs of a right triangle squared, the sum of them is equal to the length of the hypotenuse squared. And we can say that in this situation that, d squared plus e squared equals f squared, because we're comparing these two triangles here. So given that AB is congruent to DE. So AB is congruent to DE, two tallies, two tick marks, and AB equals DE. Well, duh. And C equals F. Okay, side length. Therefore, you can say that C squared equals F squared, and A squared plus B squared equals A squared plus E squared. You can substitute because they're equal. Wait, I just jumped again, I'm sorry. This is supposed to be a D. Can't read. It's like, it is given that BC, we already know that BC is already congruent to EF, right? One tally mark. So therefore, that we know these are equal and A and D are equal. So if you substitute A in for D, this is where I was going. Then you have A plus E squared. So subtracting A squared from both sides, so if you see what would happen if you did that, you get rid of it, and then you have B squared equals E squared. Now if you take the square root, you have B equals E. Now that's important, B equals E, because that would show you that that third leg is congruent. So you can see that AC is congruent to DF. Therefore, these triangles are congruent by the SSS triangle congruence theorem. So you took the HL, trying to do it via the HL to prove that it's congruent using all three sides. Still true. You just did that. Alright, your turn. If you want to pause, try this. So, determine if there's enough information to prove. So we've done one just like this now. Look what is congruent, look what's not. You have a leg and a leg congruent. So we know that they share a hypotenuse, right? It's kind of hard to tell, but this is a shared hypotenuse. And you know that those two are congruent. So you know that you have a leg congruent, so you have WV is congruent to YX, right? And you can say that WX is congruent to WX via the reflective property of congruence. So therefore, the triangles will be congruent by the HL because you have the leg and the hypotenuse, and that's true, and we proved that using SSS. So you don't have to go all the way through. Now, if you didn't trust it and you had numbers, you could actually prove this. But right now, you just got to say proven by HL, right? The two triangles, that's supposed to be a V, are congruent by the HL triangle congruence theorem. Done. And the only type of triangle you can use Pythagorean Theorem on, in case you forgot, is right triangles only, and right triangles are triangles that are not wrong. They're not left. So, here we go. Apply it. So, P and R are right angles. Obviously, those are congruent, right? All right angles are congruent. We know that PS is congruent to RQ. Now, these two triangles obviously share a hypotenuse, so you should already be clinging reflexive property of congruence. These are already common. So you have a leg, you have a hypotenuse, this is already done. Bam. It's that simple, because if you had to go forward and you had values, you could prove that this is congruent to this. But we ain't got to do all that, because we're smart. We know stuff. We know things. Alright, so J and L are right angles, right? That's given to us. K is the midpoint of JL, and MN, that's also given. You very clearly can see that. JK, so JK is congruent to LK. Just kidding. And MK is congruent to NK. That's via the definition of the midpoint, right? If K is the midpoint, it clearly intersects these lines at its midpoint. Def of midpoint, if you forgot that, I think it might have been, is that module 1? Whew. This has been the longest year in history of years. So, now that you know that you have the leg and the hypotenuse, and they're both congruent, HL, triangle congruence theorem. Theorem. It's that simple, guys. That's simple. Is it possible to write the proof in part B without using the HL triangle congruence theorem? Yeah, if you wanted to, and if you remember we have done one like this, you could use SAS. And you could say that it's vertical angles, and that the vertical angles are congruent, and you have side angle side. Yep, side angle side. So that would work too. Alright, your turn. You want to pause, try this? Go for it. So, right angles, congruence. So this is congruent to this. Prove that they're congruent. So, it is given that those are right angles, clearly, and we know that these two are congruent. So, AB is congruent to itself, right, via reflexive property of congruence. Reflexive prop, right? So, therefore, you can already prove, because you have the hypotenuses, and now you have a leg. Right? If you draw the triangle, let's use a different color, draw the triangle. We know that the hypotenuses are congruent, and I'll draw that in blue. We know that the leg is congruent. I'll draw that in purple, and you have a hypotenuse and you have a leg. The whole thing is congruent. So here's a little bit of a trickier problem if you want to try it real quick. But anyways, if you draw a right triangle with a hypotenuse of 5 inches long, your friend draws that right triangle with a hypotenuse of 5 inches long, can you automatically say that they're congruent? And the answer is no, because just knowing the hypotenuse is not enough. You need to know one of the legs and make sure that they're congruent. How is this similar to the others? Well, it's similar because it gives you criteria so that you can prove that two triangles are congruent. So just like the others, if you can meet the criteria, it works. It's different because this is only for right triangles. So you have homework that you can do. Get used to this. You have 5 theorems in your bag now. Pull that out the bag. You guys got all these tools. Use them. You know, if you're trying to push yourself, make sure you can do the more challenging things. I really think that's all I got, guys, because this one was quick. It's HL. So we got ASA, SAS, SSS. I forgot the fourth one. This is why you need notes. Let me scroll up. Let me cheat. Hypotenuse leg and ASA, SAS, AAS, SSS, HL. You see why it's a lot. Plus we got all the CPCTC and all those angles. Your brain's probably mush. So make something to help your study. Make something to help your review. Again, like always, that's Mr. Hanson at Mr. Hanson 414. Hit that like button, hit the subscribe button. I'll see you guys later. Thanks for messing with me on this geometry.